Hey everyone, it's Sam, and today in the lab I thought I'd share some soldering and desoldering tips with you in the context of a real project. I'm currently restoring this Farfisa mini compact organ, and I'm going to be replacing all of the electrolytic capacitors on the 12 tone generator boards, so please stick around.
Alright, so here we are with the Farfisa mini compact organ. This is the G sharp card that I'm going to be working on. And this one, as you can see, does not have the 50 microfarad cap here like some of the other boards do. So we have a total of 7 electrolytics to replace. So looking at the back of the PCB, you can see the solder connections for the 1 microfarad caps going across the top here. And then at the bottom, we have the 25 microfarad cap. So to desolder them, I'm just going to start by tinning each connection. Adding fresh solder will help speed up the melting process when I go in to actually remove the solder. I'm using a 6337 alloy with a rosin core, similar to what this organ was originally built with. So I'm just going to quickly go through and add solder to each of these joints. My work surface here isn't ideal, but I didn't want to have to remove the entire board from the cabinet, so this is the best setup I could figure out. When the iron starts smoking a lot like this, you want to clean that flux residue off quickly. This will help prolong the life of the iron tip. A wet sponge or brass coils will work just fine. And then you're ready to continue soldering. Now, on a side note, soldering fumes are just as bad for you as they are for your tip. You can see here I'm using a fume extractor to redirect the fumes away from my face for a safer working environment. You can actually see all the contaminants getting stuck in the carbon filter, all that white residue. Alright, so at this point we have fresh solder on all of our joints. Now we're going to go in and start removing as much of that solder as we can with our manual desoldering pump. Now this may sound counterintuitive, but the new solder helps the old solder to activate and melt quicker, so it's going to make the process much easier. The goal here is to clean each hole entirely, but it's okay if you can't. It's always best to avoid overheating, so if you think you've spent too much time on a joint, just move on to a new one and come back to it later. In the desoldering process, you'll find the pump is going to fill up quickly. It's a good idea to keep it as empty as possible by cleaning it out in between removals. I do this by firing off the trigger a few times to get the solder out. I just keep a paper bag on the floor to collect the remnants. If you don't clean the pump like this, it is more likely to jam up from the solder residues cooling and getting stuck in the vacuum. So when this happens, you have to open it up in order to clear it out properly. On this project, I found it difficult to clear the holes because the component leads were bent over on the pad. So here's a trick that I used. If we look on the top side of the board, we can see the component lead coming up through the hole before getting bent over the pad. A great way to handle this is to heat up the pad and push the lead up through the hole to get the bent part in the air. Make sure the solder is completely melted before you push up so you don't damage the pad. But this gives us the clearance to simply snip off the bent part so we can pull the lead out cleanly. Like so. Now we can easily remove the other side. First I'm going to clean the hole a bit more, again by adding a bit of solder, which helps it all get molten quicker. Once it's clean, all I have to do is apply heat to the joint and gently rock the capacitor out. I'm applying just a bit of pressure at an angle in order to get that bent lead through. Now we're just going to repeat the process on all the 1 microfarad caps going down the board. This component was being a little difficult, but it's important to not pull too hard as to damage the pad. I simply just added more heat and pulled it out cleanly. Here I'm inspecting the board for any closed holes so far. I want to get them all cleared up in preparation for installing the new parts. This part was being really stubborn, so I tried using pliers because I was heating it up too much and it was burning my finger. But that still didn't work. And again, you don't want to yank these things out because you're going to damage the pad on the other side of the board. So what I decided to do here was just move on to the 22 microfarad cap while I let the joint cool. Another good way to remove these caps quickly is to cut the lead right in the middle so you can pull it right out from the base. Be sure to leave enough room on the lead so you can get the small piece out. Here I'm just gonna heat the joint and push it right out, just like that. Now I can heat up the other side and just pop the small lead right up and pull it out. You can see that burned a little bit, so you might want to use pliers instead of your finger. And with that, we have a completely cleared board and we're ready to solder in our new components. Now I'm going to prep my new parts for installation. I wanted to keep a similar aesthetic, so I'm using the same axial type capacitors, and I'm also going to reuse these little yellow protectors to mark the positive side of the capacitor. With all those pieces collected, I'm going to start forming the leads for these 1 microfarad caps. You want to make sure they are straight as possible to start. I'm then going to use needle nose pliers to form a clean bend like the original had. Use the jaws of the pliers as a measurement device to get the same bend on each one. Starting from the base of the cap, the deeper in the jaw you go, the further down the lead the bend will be. So once you found the spot, hold the pliers steady and with your other hand bend the lead around the jaw. If you mess up, you can always put the pliers in the same spot and bend it back into place, and then try again. So I'm just going to go through and do this to all of them. These leads have a lot of length on them, so to make it a bit more manageable, I'm going to trim them down before installing. I'm just using flush cutters to cut them to equal length. The longer of the leads is used to identify the positive end, but I'm using these yellow markers, and you can tell from the markings on the cap itself. So to install these, I'm just going to slide the yellow marker cap onto the positive leg, and then I've got another trick to help you with soldering these too. Now it's going to be pretty difficult to get the cap to stay in the position that we want it, So what I'm going to do is tin the tip and then tack one side of the lead while holding the cap in the correct position. You want to add a little bit more solder than you normally would to tin because you're trying to get a decent enough connection to hold the component with only one hand. While still holding the part, remove heat and wait for it to harden. Then you can move over to the other side of the cap and make a true solder connection. Later we'll go over all the joints and clean up the tacked sides by adding more solder. So now I'm just going to continue tacking in all of these caps. Here we have all of our 1 microfarad caps in and it's looking good. Now we just have the 25 microfarad cap at the bottom, which I'm going to be replacing with a 22 microfarad. For this one, you can just push the leads straight through, making sure the polarity is correct. For me, the leads seem to stay in place just fine, but if you want, you can bend the leads in opposite directions for more stability. Now that we have everything tacked in place, we're gonna go over all of the joints here and make sure there's a good solid solder joint. These pads have a lot of solder on them, almost like a blob that encompasses more than one component. Because of the larger surface area, it takes more time to heat the whole mass to a molten state, and therefore adding a lot of flux core solder wire helps. You can see I'm spending a decent amount of time on each joint making sure they wet completely. Sometimes it even helps to move the iron around just to get it melted and then keep it steady to form a proper joint. Now all there's left to do is cut the component leads. Snip one at a time and discard the pieces. And there we have it, a completed board with all new electrolytic capacitors. And from the way we did it, you can hardly tell that it's not from the factory. I hope this video was helpful and gave you some good soldering and desoldering tips for your projects. For more content like this, be sure to like, subscribe, and hit the bell icon to be notified as soon as new videos come out. Thanks for watching.